we want to look at the trig ratios. Basically, sine, cosine, and tangent are the ones that you guys are used to. We're going to introduce to you the other trig functions, cosecant, secant, and cotangent. One thing that we need to make sure is that we recognize exactly how we're going to be looking at this particular triangle. We are focused on triangle, or the angle A, right? We've got theta right here, and what we're looking at here is the fact that sine, cosine, and tangent of a particular angle, of course all the other ones as well, we're going to label this adjacent, opposite, and we're going to go ahead and label the hypotenuse as well. Whenever you're looking at a triangle, this is how you're going to remember what sine, cosine, what all the 6 trig functions are, right? We know that sine is the opposite over the hypotenuse, right? Make sure that you realize that the opposite of the triangle is always across from the angle that you are working with. The adjacent is going to be right next to it. And so if I were to move angle A, say from up here down to this side, then this becomes the adjacent and that becomes the opposite side. The hypotenuse will always remain the same. So this is a relative term. So if you move around, you know that it's going to switch. Cosine is going to be the adjacent over the hypotenuse, and tangent is the opposite over the hypotenuse. Now, sometimes people learn this as Sohcahtoa, right? S-O-H, that's so. C-A-H is ka, and then T-O-A is toa. I should fix that A down there. And whether you remember that or I've learned it other ways, like Oscar had a heap of apples, however you want to do it, right? It's not a big deal. Just this is something that you're definitely going to want to have memorized and be able to use at any time. With the other trig functions, right? Cosecant, secant, and cotangent. These are not just simply put out there. They're put in such a way that sine and cosecant are reciprocals of each other. And by reciprocal, I mean the mathematical definition by where you can flip over a fraction and you have the reciprocal. I don't mean the opposite, right? So don't think of it as that. In math, opposite would mean positive versus negative. Cosine and secant are also reciprocals, and so we can say that's the hypotenuse over the adjacent, and tangent and cotangent are reciprocals as well. So adjacent over opposite. Now, the one thing I remember about this is that you're going to have to be able to keep these paired up. So really, if I've told you one of them, I've told you both of them because you can just simply flip the fraction over. So what I'll give you as a tip is sine. So these are paired up, right? One and its reciprocal. You can never put two cofunctions in the same pair. In other words, sine and cosecant. Cosine and secant, and of course tangent and cotangent, those are matched up pretty well. So if you ever put sine with secant, you know that can't be right because sine and secant, neither one of those is a co-function, right? So cosine has to go with secant and cosecant has to go with sine. We know that sine can't go with cosine. These two don't match. I think if you remember that, then getting these right are relatively easy. I want to go through some examples now and show you how to apply the 6 trig functions. With the ratios, each of the 6 trig ratios, then I can kind of work through some problems like this. Now, it looks like I've only given you a little tiny bit of information, right? So we know that the sine of some angle is equal to 5 over 6. But really, I've given you a wealth of information here if you know how to kind of apply what you've been told. We know that sine, cosine, tangent, all the ratios only work in this way using a right triangle. So I'm going to go ahead, I'm going to pick an angle, and it doesn't matter where you pick it, just don't pick the right angle, right? I know that the sine is the opposite over the hypotenuse. So I'm going to go ahead and I'm going to label these pieces, right? So this is the opposite side, and this is my hypotenuse. Really, this is the symbol for cosecant. I really already know this one. It's going to be just 6 over 5. So anytime I ask you a question like this, if I said list the 6 trig functions, really I've given you 2 for free. We can find the cosine of theta, tangent of theta as well. However, I'm not quite ready to write out any of these. each one of the rest of the trig functions is going to need to use the adjacent side as well as the opposite side in others, right? So I'm good on opposite, but I'm not good on the adjacent. So how do we find it? Well, this brings up one of our more popular theorems, a squared plus b squared equals c squared. Now be careful, there's two things that I have to remember about the Pythagorean theorem. Number one, it only works on right triangles. Well, fortunately, we're working with right triangles. Number two is that when you use this, c must always be the hypotenuse. If you plug anything else here, it doesn't matter what happens, it's going to be wrong. Not to mention that when you find your two sides here, we know that they're shorter than the hypotenuse. So if you ever get a side length that is less than the hypotenuse, you know you've done something wrong somewhere along the lines. So what I'm going to do now is I'm going to plug these in and solve for my missing side, right? So we're going to have 5 squared plus, we'll call it a squared plus, or equals b squared, or c squared, excuse me. So equals, c squared in this case is going to be 6 squared, right? So a squared is going to be equal to, that'll be 36 minus 25. So a squared is 11. That would make a the square root of 11. And do not turn this into a decimal. I want the exact answer. So the square root of 11 will remain just like that. It can't reduce. 11 is a prime number, so we're going to leave it alone. If I had said something like the square root of 20, well, I can do that. That's 4 times 5, so it would be 2 times the square root of 5. But we'll get to that later. I'm going to go in and I'm going to go ahead and write out all of the trig functions using the adjacent, the opposite, and the hypotenuse for all of the following. You can look back at your ratios if you don't remember them, and perfectly fine to look at them right now. If this is something new to you, especially if you have some other trig functions you're not used to, please look it up. In fact, every time you do a problem, write this stuff down so that you get practice doing it. So the cosine is going to be the adjacent, which is going to be the square root of 11 divided by 6. And I'm going to change this one. It's just going to be 6 divided by the square root of 11. Tangent is going to be the opposite over the adjacent. Cotangent, the square root of 11 over 5, the adjacent over the opposite. Now, a little word on radicals. Things like this. Mathematically speaking, there is nothing wrong with you putting a radical in the denominator. Right? There's nothing wrong that like dividing by 0, that you can't do that. That's not a thing. But this is a thing. It's just not as nice as we want it to be. When you get multiple choice questions, especially if it's done through a computer program, your answers are going to be rationalized. So we need to learn how to rationalize something. So we're going to do that. We're going to take the secant. It's 6 divided by the square root of 11. To rationalize a fraction, meaning I need to get rid of the radical in the denominator, and it's going to look like this. You're going to multiply the top and the bottom by that radical. The square root of 11 times the square root of 11, well, I can do, it's 11 times 11. That's going to be 121. But what's the square root of 121? It's 11. Anytime that you multiply a radical times itself, you know that the radical is really just going to cancel out. The top part's going to be 6 square roots of 11. And this is, if I were using this on a multiple choice, the secant would look like this one. Okay, mathematically, if you were to type these two things into your calculator and divide them, you would get the same exact decimal answer. Okay, so mathematically speaking, both are correct, but you're probably going to need to know exactly how to rationalize something that looks like this. Okay, and we're going to do an example in a minute, which is, I'll show you why. And this is how you do it. And I've got all 6 trig functions, right? I can rationalize them or not. Pay attention to what your teacher asks. If they want you to rationalize it, please rationalize. If they don't, then it's not a big deal. The next question, solving a right triangle, right? In this example, and in most examples, I'll give you 3 parts. I'll have to give you the 90-degree angle and a side, and then I'll have to give you one other thing. In this example, I have one side and 2 angles. And so what we're going to do, obviously I'm going to find angle B first, right? So 90 minus 37 is 53 degrees, right? So B is 53. Side length B is a little trickier. I do know that I have angle 37. I'm going to pick this one to work with because I know it's correct. Hopefully I didn't make a mistake on B, but it's possible. I'm going to circle the thing I want to find, and two of the things that they gave me. Which trig function uses these three pieces? I have an angle, I have its adjacent side, and I have the hypotenuse. Which trig functions, and typically when I'm working on a problem like this, I'm going to stick to sine, cosine, and tangent, because I may have to pull my calculator out and work with it some. I may not, but in cases I do, I don't want to use secant, cosecant, or cotangent because those are more difficult to use in the calculator. So adjacent and hypotenuse is cosine. So we're going to write it out. We know that the cosine of 37 is equal to the adjacent side divided by the hypotenuse. In this example, I can type this into my calculator. I need to make sure that my calculator is in degrees. If you have a TI calculator, usually on the screen somewhere you'll have the three letters DEG or RAD. If I'm using radians, then radians is appropriate. In this case, we're using degrees. If you have a TI-84, the second button on the top row is your mode. If you'll press that button, make sure that the degrees has been selected. By default, it's actually radians. So you might need to change it if you've never done this before. I'm going to do this, and this is an equation. So we're going to solve for b, right? So we're going to multiply both sides by 8. That's going to cancel out here, and b is just going to be 8 times the cosine of 37. And I recommend you multiply it in that order. If you put the 8 at the end, you tend to run the risk of not closing that parentheses and putting it inside the cosine, and then it's just all going to be bad from there. So do it this way first. When you multiply 8 times the cosine of 37, you're going to get the side b is equal to 6.3, we'll go to two places, 6.39. I guess this is inches, who knows. Okay. One thing to note, anytime I'm finding the side lengths, I want to make sure that it's less than my hypotenuse. Let's find side A. In this example, if I use 37 again, and I'm going to have to use 8 again, and I'm going to use A, which trig function would this work with? I know that I have the opposite and the hypotenuse. So that means I'm going to be working with sine. So for part 2, we're going to set it up as the sine of 37 is equal to A, the opposite, over the hypotenuse. And as you can see, I'm in very, very similar territory, just like we did before. So we're just going to kind of take that. Sine, or 8 times the sine of 37 is equal to side length A. So sine times, actually 8 times the sine of 37. Make sure to type it in that way. Make sure you're in degrees, and you're going to get A is equal to 4.81. And this solves my triangle. I note that I have a number of solutions. We have A, we have B, and we have 53. These are the 3 solutions. When I'm solving a triangle, I'm always going to have 3 different solutions.